So, good evening. In the strength of materials, we discuss about the topic second unit, that is torsion and springs. In the torsion, we have to find out the strength of the solid shaft and hollow shaft. In the springs, we have to find out the shear stress, number of coils required for the springs, and what is the diameter, wire diameter is required, what is the mean coil diameter is required. Okay, so these are the things we have to study in this unit 2, that is torsion and springs. Let's go for the torsion. Torsion, and that is torsion is nothing but the shaft is said to be a torsion when the equal and opposite torques are applied at the two end of the shaft. Okay, the two equal and opposite of the forces, okay, that is applied. Okay, then the shaft should be said to be a twisting movement. That twisting movement is nothing but torque. The torque is equal to the product of the force applied and radius of the shaft. Okay, this is known as torsion. And so the formula to find out the shaft, okay, that is see here the torsional equations, that is tau by r equal to c theta by l equal to t by, there is q by r. The q is nothing but that is the twisting forces. Okay, so these are the things you have to remember in this unit. So what are the assumptions we required in this unit? That is, the material of the shaft is uniform throughout. This is the first assumption. Okay, the material should be uniform. The second one is the twist along the shaft is uniform, that is twist, that is theta. The third one is the shaft is of uniform cross circular section. When you calculate the shaft, okay, the strength or something, okay, so the shaft is of a uniform circular cross section throughout the body. The fourth assumption is the cross section of the shaft which are plane before twist remain plane after twist. Okay, before twist and after twist, that should be a same. Okay, then all the radius which are straight before twist remains straight after twist. Okay, these are the things we have to calculating the strength of the shaft, remember. Okay, so the maximum torque should be for the circular solid shaft. Okay, this is the formula to find out the maximum torque. Okay, so that is pi by 16 into tau into d cube. Okay, this is the formula to find out the maximum torque for the solid shaft. Okay, so tau is nothing but shear stress and diameter d is nothing but that is the diameter of the solid shaft. Okay, similarly the formula to find out the torque to find out the hollow circular shaft, this is the formula to find out the maximum torque. Okay, that is pi by 16 into tau into d outer power 4 minus d inner power 4 divided by d outer. Okay, so this is the formula is used to calculate the torque for the hollow shaft, that is pi by 16 into tau into d outer power 4 minus d inner power 4 divided by d outer power 4. Okay, so the power transmitted by the shaft, that is p equal to 2 pi nt divided by 60. The n is nothing but speed of the shaft and t is nothing but torque. Okay, there is a mean torque transmitted by the shaft. Okay, so see on sum in this torsional sum. Okay, so this is the sum. A solid circular shaft and a hollow circular shaft whose inside diameter is 3 by 4 times of the solid circular shaft and a hollow circular shaft whose inside diameter is 3 by 4 times of the outside diameter or of the same material. Okay, the inside diameter is 3 by 4 times of the outside diameter. The whole circular shaft is having the same material. and of the equal length, okay, and are required to transmit a given torque. Okay, what is the purpose of these things means you have to, this shaft is required to giving a, what are the torque we required, that type of torque will be transmitted by using this shaft. Okay, so compare the weight of these two shafts. You have to compare the weight of the solid shaft and also the hollow shaft. Okay, under the maximum shear stress developed, and of the, you have to find out the maximum shear stress developed by the two shafts, okay, are equal. Okay, so the shear stress in the solid shaft and also the shear stress in the hollow shafts are equal. This is the data is given in the sum. And one more thing is the solid shaft is the hollow circular shaft was inside diameter is 3 by 4 times of the outside diameter of the shafts. Okay, and also the shaft is having the same material. Okay, the both solid shaft and also hollow shaft is having the same material, same length. Okay, but only the shear stress for the both solid shaft and hollow circular shaft is also similar. Okay, so you have to compare the weight of the two shaft, which weight, okay, which is the best weight, solid shaft is having more weight or hollow shaft is having a more weight. Okay, this is the things you have to compare this. Okay, so the diameter of the hollow shaft, that is d1 is already given in the sum, that is 3 by 4 of the diameter of the outside shaft. Okay, finally you have to calculate these things. 3 by 4, that is equal to 0.75. Okay, is the diameter of the hollow shaft. Okay, so you already know the torque transmitted by solid shaft is given by the equation, that is tau t equal to pi by 60 into tau into d cube. Okay, similarly for the hollow shaft, similarly the torque transmitted by the hollow shaft is pi by 60 into tau d outer power 4 minus d inner power 4 divided by d outer power 4. Okay, so we already given the sum, the inner diameter is 0.7 times the outer diameter, that is 3 by 4. Okay, the outer diameter. By substituting this value, then finally we get the value of, for the torque for the hollow shaft, there is t pi by 16 into tau into d outer power cube minus 0.6836. Okay, so this is the maximum torque transmitted by the hollow shaft. Okay, so the both the solid shaft and hollow shaft is used to transmit the torque only. Okay, that's why you have to equating these two equations, that is hollow shaft and solid shaft torque, that is pi by 60 into tau into d cube, that is equal to pi by 60 into tau into d outer cube minus 0.6836. Okay, the finally you have to find out the diameter. Okay, here the stress should be cancelled, because why means the shaft, the sum itself, the question itself they are given the shear stress for the both solid shaft and hollow shafts are same. Okay, that's why you have to cancel this, the pi by 16 is cancelled. Finally the diameter of solid shaft, that is equal to 0.6836 of the diameter of the hollow shaft. Okay, finally now go for the weight. The weight is, density is nothing but mass by volume. Okay, therefore weight, when you go for the weight, calculating the density with the weight means of the weight, therefore mass into gravity divided by volume. Okay, this is the formula. Therefore weight of the solid shaft is equal to rho into g into weight of the volume of the solid shaft. So density into gravity, the volume is nothing but area into length. Okay, therefore area for the solid shaft is pi by 4 d square into length. Similarly go for the hollow shaft, that is rho into density into gravity into volume of the hollow shaft. So the volume of the hollow shaft is area into length, area of the hollow shaft into length of the hollow shaft. The area of the hollow shaft is pi by 4 d outer square minus d inner square into length of the solid shaft. Okay, now we have to be getting this, now we have to dividing the solid shaft and hollow shaft weight. Okay, this rho cancel and g cancel, pi by 4 cancel, and d square into length of the materials, all the things are similar. Okay, now go for this, that weight of the solid shaft divided by weight of the hollow shaft, that is 1.7737. okay, compared to the, this is the ratio of the weight of the solid shaft to the weight of the hollow shaft. So the weight of the solid shaft is 1.77 times greater than the hollow shaft. Okay, so this is that actually. So the next topic, that is springs. The springs is nothing but is one of the elastic body which absorbs energy due to resilience. Okay, so that is that nothing but springs. Okay, The observed energy may be reached as when required. Okay, a spring which is capable of observing the greatest amount of energy for the given stresses, okay, without getting permanently deformation or distorted. This is known as the best spring. Okay, there is a two types of spring. One is the laminated spring, another one is the helical spring. Okay, this is the laminated spring. This is most used in the automobile sector, and the helical springs also they are most used in the uh, automobile sector for observing the springs, and most of the industries they are using the springs. Okay, spring is one of the mechanical members, okay, that is used to observe the energy. Okay, so that is the springs. Okay, so next one, this is the closed coil helical springs and open coil helical springs. Okay,